Okay, so let's have this one. Identifying length of confidence interval. And these are the different confidence coefficient. So if the confidence level, that's 85%, then the confidence coefficient, that's 1.44. For confidence level 96%, so the confidence coefficient, that's 2.05. Then these are the different formulas we're going to use in solving for the interval. We have this sample mean minus the margin of error for the lower boundary, and sample mean plus the margin of error for the upper boundary. So to solve for the margin of error, we have this confidence coefficient times the standard deviation over the square root of the sample size. So we have this given, so construct a 99% confidence interval for the population mean based on the information given. So we have the sample size, that's 225, sample mean, that's 92.4, and the standard deviation, that's 8.5. So first, solve for the margin of error using this formula. Since the confidence level is 99%, so the confidence coefficient, that's 2.58. So we have 2.58 times the standard deviation, that's 8.5, divide by the square root of the sample size, that's 225. So to solve for the margin of error using calculator, so 8.5, then divide by the square root of 225, then equals times this 2.58, so that's 1.462. So this is the margin of error. Then to solve for the confidence interval using this formula, so for the lower boundary, that's the sample mean minus the margin of error. We have 92.4 minus 1.462. Then for the upper boundary, that's the sample mean plus the margin of error. So 92.4 plus 1.462. So simplify. We have 92.4 minus 1.462. So this is the lower boundary, that's 90.94. Then for the upper boundary, that's 92.4 plus 1.462, that's 93.86. So therefore, 99% confidence that the population mean lies within or lies between the interval 90.94 and 93.86. Then for this problem, so a random sample of 110 students from a certain school yields mean GPA, that's 2.51. With sample standard deviation as 0.47, then construct a 90% confidence interval for the mean GPA of all students at that school. So first, we need to list all the given. So we have this sample size, that's 110. So n is 110. Then the mean, that's 2.51. And we have this standard deviation, that's 0.47. So solve first the margin of error using this formula. Then since the confidence interval, that's 90%, so the confidence coefficient, that's 1.645. Then times standard deviation, that's 0.47 over the square root of 110. So margin of error now, we have 0.47 divided by the square root of 110 equals then times 1.645, so that's 0.0737. So 0.0737. Then solve for the confidence interval using this formula. So for the lower boundary, so sample mean, that's 2.51 minus the margin of error. And the upper boundary, so sample mean plus the margin of error. Then simplify. So we have 2.51 minus 0.0737. It's 2.44. Then for the upper boundary, 2.51 plus 0.0737, it's 2.58. So therefore, 90% confidence that the mean of all students' GPA on that school lies within the interval 2.44 and 2.58. Then for this problem, since the given is a frequency table, so we need to solve first for the mean and the standard deviation. So in this case, we're going to use a table for us to understand the distribution. So first, to solve for the mean, we need to find the value of fx. So fx, that's the product of x and f. So that's 0 times 21, that's 0. 1 times 8, that's 8. 2 times 5, that's 10. Then 3 times 6, that's 18. 4 times 3, that's 12. And 5 times 2, this one is 10. Then to solve for x minus the sample mean, since we don't have the sample mean yet, so we need to solve first this sample mean. So to solve for summation of f of x, so you need to add all these numbers. So that's 8 plus 10 plus 18 plus 12, then plus 10, that's 58. So summation of f of x, that's 58. Then for summation of f, so add all these numbers. So we have 21 plus 8 plus 5 plus 6 plus 3 plus 2, it's 45. So to solve now for the mean, the 8 divided by 45, it's 1.29. So this is now the sample mean. So to solve now for this column, so we have this x minus the mean. So 0 minus the mean, that's negative 1.29. Then we have this 1 minus the mean, that's negative 0.29. 2 minus the mean, so 2 minus 1.29, it's 0.71. 3 minus the mean, so 3 minus 1.29, that's 1.71. Then 4 minus the mean, 4 minus 1.29, that's 2.71. Then this 5 minus the mean, that's 3.71. Then we have this, the square of this column. So just take the square of these numbers. So when squaring a negative numbers, you need to put inside the parentheses. So we have this negative 1.29 squared. That's 1.66. Then this negative 0.29 squared, it's 0.08. Then 0.71 squared, that's 0.50. 1.71 squared, 1 squared, that's 2.92. This 2.71 squared, so that's 7.34. And 3.71 squared, it's 13.76. Then the last column, so that's f times x minus the mean squared. So this column times this column, so multiply these two columns, start with 21 times 1.66, so 21 times 1.66, it's 34.8. Then this 8 times 0.08, so 8 times 0.08, it's 0.64. Then 5 times 0.50, 5 times 0.50, it's 2.5. Then this 6 times 2.92, 2.92, 17.52. This 3 times 7.34 times 7.34, it's 22.02. And this 2 times 13.76 times 13.76, that's 27.52. Then to solve for the standard deviation using this formula, so we have the summation of f times x minus the mean squared. So we need to add these numbers. So 34.86 plus 0.64 plus 2.5 plus 17.52 plus 22.02 plus 27.52. So we have 105.06. So the square root of 105.06 divided by summation of f, that's 45 minus 1. So to solve now for the standard deviation, so we have this square root, in parentheses, 105.06 divided by this 45 minus 1, that's 44, then equals, so this 1.55. So this is now the standard deviation. So to solve now for the confidence interval, so these are the values. So for sample size, that's 45. For the mean, that's 1.29. And for standard deviation, that's 1.55. So solve now for the margin of error. Since the confidence level is 95%, so therefore, the confidence coefficient, that's 1.96. So 1.96 times this 1.55 over the square root of 45. So the margin of error now, we have this 1.55 divided by the square root of 45 equals 10 times 1.96. So it's 0.4529. Then to solve now for the confidence interval, so for the lower boundary, that's 1.29 minus the margin of error. Then for the upper boundary, that's 1.29 plus the margin of error. Then simplify. So for the lower boundary, so we have this 1.29 minus 0.4529. So that's 0.84. Then for this upper boundary, so 1.29 plus 0.4529 It's 1.74. So therefore, 95% confidence that the average number of days absent of students on that school is between 0.84 and 1.74.